I'll just give it a minute or two for people to settle down. Other than that, good morning. My name is Nikhil Barthwal, and I'll be talking about implementing cloud CI/CD. And specifically, the agenda I have is, first of all, I need to define what the limitations of CI/CD tooling is, right? I mean, you're trying to solve a problem, but first you need to understand why the problem came in the first place. And we are talking a lot about cloud-native technologies, so we need to understand what exactly is cloud-native technologies and what are the various elements that make up. Cloud-native CI/CD presents some unique challenges, and obviously there are benefits. That's the reason why we use it, which are unfortunately not addressed with traditional CI/CD tools. So I'll be talking about what these challenges are and what the benefits is, or in other words, why should we even care about it in the first place. And towards the end, I'll be talking about some sample CI/CD tools for the cloud-native world. Now, this is a big space. So what I've basically done is I've picked the 3 most popular open source tools that are there. But I mean, if you were to Google, there are a lot of open source tools and there are a lot of proprietary tools, right? In the given amount of time, I obviously don't really have time to cover all of them. So I just picked the 3 most popular one, Tecton Pipelines, which is both a CI/CD framework and tool. I talk about Jenkins X, which FYI is very different from Jenkins. And I talk about Argo CD, which is more on the deployment side of it. Okay, so before that, what are cloud-native technologies, right? So we hear a lot about cloud-native. What specifically are we talking about? So this is a textbook definition of what cloud-native technology is, right? And I picked it up from the CNCF website. And when you look through it, you see certain buzzwords here, right? Modern, dynamic environments, containers, microservices, et cetera, et cetera. But essentially, what cloud native is that, unlike the traditional, on-prem world, or even if it's on-prem, like if it's your private data center, unlike the traditional single server model, distributed systems have different components that work together in a loosely coupled way. And when we have these distributed components, what happens is that we run into what is a partial failure. Some of the components work, some of the components might fail. We need a way to recover. So that's the reason why we have a loose coupling, in the sense that different component system can withstand a partial failure. These systems operate at a scale, at a very big scale that we have never previously operated. So at a scale, we'll have unexpected surprises that we generally don't have if we are running in our small environments. So specifically, when I talk about cloud native, I actually have 4 major elements of cloud native technologies. We have the DevOps. Everybody kind of understands DevOps, but essentially it's an intersection of developer and operations. It's basically taking a programmatic approach to operations, right? Deployment, etc. We have continuous delivery. So every check-in is a release candidate. We integrate it, we deliver it continuously. We talk about microservices, because microservices is kind of a foundation of loosely coupled systems, right? Gone were the days when we were having one big monolith. There were too many problems that happened there. And then we talk about containers. Containers are also some of the well understood technologies, but I'll just cover a little bit about containers for those who don't know. So these are the 4 elements of cloud native technologies that I specifically talk about here. So let's talk about a traditional CI/CD approach. Now, take what I'm saying with a pinch of salt, and the reason why I'm saying that is because some of the shortcomings over a period of time have been addressed by traditional CI/CD tools in different capacities. So we'll talk about that. But the good old system was that there were these teams, there was some distributed source control, right? There will be a server that you would be pulling for changes. So I have I check in, I have a release candidate. There are a couple of build agents. In the good old days, these were static agents. They were always on. Modern CI/CD tools generally make them dynamic. We'll talk a little bit about that. And they would build and release. Every day, there's a new CI/CD tool coming. Here are the most common ones. But the problem with this approach is that it's not cloud native, right? It deals with, it doesn't talk about containers, it doesn't talk about Kubernetes, it doesn't talk about distributed systems, etc. And it's hard to scale, right? What if I have a system where my peak hours are going to be during the day, but at night I I don't have a lot of work going on, but if I have an always-on build agent, it's going to run 24/7. During the peak, it's going to crash, and during the downtime, I'm just paying for it. These shortcomings in various capacities have been addressed by certain tools. So nowadays, tools get a little bit smarter. They say, okay, fine, the build agents will make it on demand. So AWS has what is called as instance, like spot instance, right? So they can be very cheap instance that run for 1 hour. So you spin them up. Google has the same thing. They call it compute instance. Azure has something similar. I think, I don't know exactly the term Azure uses. So build agents over the years have smartened. They actually have a scalable system where you can scale up and down the build agents. But the thing is that no matter what approach you do, these systems were never designed to be cloud native, right? So you can address the shortcomings, you could fill these gaps, but that's about it. Like, you cannot fundamentally change the behavior. When we move to the cloud native world, we encounter problems that we have not encountered in the traditional CI/CD world. These tools would basically fail at that level. They can address some of the shortcomings, but they won't be able to address all of them. So we want something new. So what is the problem with traditional infrastructure? Before we go into cloud native world, we want to drill down a little bit about what particular problems are we facing, right? To start with, there's a lot of complexity going on, right? Too much of effort. We can't really automate everything. Traditional infrastructure can be very complex, right? They're hard to maintain. There's a lot of difficulties with dependencies and so on, so it's very difficult to debug or extend. Then they can be very error prone because we are talking about different environments, different permission settings. IAM can be a headache. So then we talk about reliability. In fact, this is something that kind of container addresses, but when you're building on a build agent, your system that is being built, interacts with an environment. So it's built in a certain environment, and when the environment changes, sometimes it doesn't work. This is the foundation of entire discipline of chaos engineering, but we have already been at spots where I build something on my local machine, everything works, I put it on my production environment, I put it on my dev environment, works, staging environment works, I put it on my production, things fail, I don't know what happened. And the reason is that while the code remains the same, the environment changes, right? There could be different versions of libraries, there could be different versions of dependencies, etc. So reliability here becomes a big problem in the traditional world. Then, of course, there's cost, right? I have these servers, I have these environments, they're operating on always on. As I mentioned, this is the part that has somewhat been solved in some of the CI/CD tools. Not to the extent we would want that, but at least partially. So now, when we talk about cloud native world, what specifically are we talking about? So cloud native essentially is an approach where we are building and running applications that take advantage of our standard cloud computing model, right? We talk about all the distributed systems, scalable systems, et cetera, et cetera. And here are some of the stats that I picked from this website. So when we look at like services in production, you see like we are talking about, I don't know, hundreds or thousands. There was a point in time where Uber had 7,000 services in production. I don't know why, until they realized that that was a little bit too much and they scaled it down. I don't know what the final number is today, but it's still in thousands. Probably not 7,000, but still in thousands, right? You have this many services that are operating and they are deploying very frequently, right? So you need a model that is more elastic, which is what traditional models don't really support. So we have talked about the cloud native world. Now we talk about like what are the characteristics of cloud native CI/CD, or actually desired characteristics of cloud native CI/CD specifically. Containers, which I'll define a little later, but I think it's a well understood technology. Applications are built and packed in containers. So we need a system that has a first class support for these containers, right? So we have immutable infrastructure. Once we pack up the infrastructure, services are not modified after they are deployed. We want pipelines that are declarative, right? We want pipelines that are declarative, that are composable in the sense that I have pipelines, I have sub-pipelines, I'm building an Android app, I should be able to take this pipeline, I should be parameterized, I can mix and match these pipelines to build like higher order pipelines. I don't want to go into nitty-gritty details of implementation. I want it to be having first-class support for platform. Kubernetes is by far the most common one, but there are some companies and some organizations that use mesospheres and others one which are less popular. Nevertheless, they're there. And then most important, we need these elastic dynamic agents, right? Because my environments are ephemeral, I need dynamic agents that can scale, environments that I can spin up and spin down based on my needs. When we are operating at scale, specifically when we are deploying like hundreds or maybe thousands times, cost can scale up. So what I want is I want resource utilization to be optimized so I keep the cost in control. So these are the characteristics, the desired characteristics that I want in a CI/CD tool. But the question is, why should I even care about it? Are there any benefits? The answer is, of course. There are a lot of benefits of cloud CI/CD. That's the reason why we are talking about it. For first part, containers gives us reproducibility and reusability. We don't really have a problem of the fact that environments can be different, right? Because once I have the container packs my service along with all the dependencies as one single unit that I can take it anywhere I want. So it's easily reproducible, it's easily reusable. I don't have surprises like it works on my machine, but it doesn't work on the cloud. Then I talk about dynamic orchestration. At scale, things fail. So reliability is a key concern. Dynamic orchestration gives me increased reliability. Serverless resource usage. Right? The reason why I want serverless resource usage is reduced cost. I'm talking about operating at a scale. If I have all these resources always on, it's going to be quite expensive. So I want to reduce the cost. Conformant APIs. If I have conformant APIs, I have portability. After all, I'm operating in many different environments, right? Portability can be a concern. Most of the organizations, especially the big one, they are multi-cloud. They have part of it on-prem for various reasons. For example, in US at least, I don't know about France, but in US, compliance and etc. is a good thing. You can't really put a data in cloud. Even in Europe, they have a law called GDPR that says something like the European citizens' data has to stay in Europe. So you can't really have like one data center where everything is operated. You need to have a separate data center for Europeans and Americans, etc. So you're operating in different kind of data centers, different kind of environments. Portability can be a big thing. So we have all of these benefits, but with benefits, we have challenges. So let's talk about what are the challenges that cloud native CI/CD presents, which is actually somewhat different from what traditional tools have. To start with, we are dealing now with containers. Traditional CI/CD tools often deal with binaries. I remember good old days about 10 plus years ago when I first used Jenkins server. There was a Java service, and all you have to do is do a Maven command in one of those configuration, and Maven will build and pack a jar, etc., right? Everything was like binaries, or in .NET world, you'll build those executables. Now we are talking about containers, which are not really addressed first class with traditional CI/CD. Then what you have is you have many different environments. You have dev environments, staging environments, production environments. Environments can differ based on their purpose. Environments can differ based on their customers. Like I might have one environment dealing with specific geographies. I might have some environments dealing with GovCloud. Governments might have their own security restrictions, etc. So we have many environments. We are using now microservices as opposed to monoliths. The problem is microservices are inherently a fragile thing. It's like because there are a lot of dependencies, right? You have loosely coupled services running independently. And then last but not the least, you have ephemeral environments. You have often environments that are short-lived. Especially if you're doing some kind of batch processing, if you're doing some kind of environment processing, you basically have this environment, you spin it up, you do it for something, and then you tear it down. Environments don't live forever. They can be short or they can run for a couple of hours depending on your needs, but nevertheless, the assumption that environment stays static is not actually true. So, moving on, we are talking about containers. Now, containers is a well-understood technology, so I'm assuming a lot of people are familiar with it, but for the sake of completeness, I'll just spend a minute or two on this. So, container is essentially, the beauty of the container is that it contains my environments with my services. So all the dependencies and everything is packed as one unit. Containers share an OS, but they run as an isolated processes, and they are portable in the sense that I can take this container, I can take this container, put it on-prem, it works, I test it, then I can take it as a stand unit, deploy it to any environments at Google Cloud, Azure, AWS. All of them basically support containers in various forms. And there's an ecosystem of base images. So there's a lot of images you can have, any language, any cloud. It's a layered architecture, right? So we have these containers. Then what do we have? Kubernetes. Kubernetes is basically a platform for managing containers, an operating system for your data center. It does a lot of automation, resource allocation, scheduling, because we talked about optimized resource allocation. So this is going to be a big thing. We want to basically what Kubernetes is, it's a descriptive system where I tell the desired state of my system, and Kubernetes controller works to make sure that is going to be always on. If I deviate, it brings back the system in control. Provision and automated deployment, load balancing, traffic routing, scaling, etc., and monitoring. But the real thing about Kubernetes is that Kubernetes is basically an abstraction. So it abstracts my underlying hardware or my software. So I have concepts like containers, I have like pods where containers would run together. That's a logical abstraction. And then you have physical machine, which is basically actual hardware abstraction. And Kubernetes is mapping those. So it will ensure that one pod runs on one machine. You could have multiple pods in the same machine, sure, but pods stay together. So pod is essentially a logical construct, whereas a virtual machine is a physical construct. Kubernetes is a big ecosystem. So there are a lot of benefits of using open source because ecosystem is very big. So it's very well supported, a lot of tools. It follows the infrastructure as a code paradigm, which is actually very helpful in GitOps. We'll talk about GitOps later on. You can version control the whole system because once you have infrastructure as a code, you can just check it in your Git or whatever version control repository you have. Kubernetes does optimize resource allocation, so you don't really have to worry about optimization, helps you in cost. Zero time, rolling updates, you have self-healing, because if you deviate from your desired state, Kubernetes controller will take care of it, spin up, self-heal, recover from that failure. And you have command line or APIs scale up, scale down with one command. And with Kubernetes, you have another thing called Helm charts, which is essentially a package manager for Kubernetes, right? So you have basically, it takes simplified deployment and management on clusters because everything is packed up as one package manager. User can define and upgrade any complex applications. And it has like a pre-configured collection of resources and templates. So in Mac or something, you have the brew or other package managers. So think of it as brew for Kubernetes in more simple terms. We'll talk a little bit about containerized pipelines, right? What are containerized pipelines? The thing about container pipeline is that it's portability, because once you have these pipelines where the steps are containers, containers are inherently portable. So you get the portability across various environments. Containers are easily isolation and reproducibility because containers run as a single process isolated from your underlying system. They are reproducible by definition. You can scale them up and down because I can spin up a lot of containers. Above everything else, you have a lot of pre-built images. So I can have a very fast build and deployment times with these containers. So there are several advantages of using containerized pipelines. And of course, because these pipelines, I can version them, roll back because they are following the infrastructure as a code paradigm. Talking about infrastructure as a code paradigm, we move into GitOps. Okay, so what is GitOps? Git as a single source of truth. What does it mean? GitOps is basically a set of practices where you follow a paradigm of everything as a code, right? Infrastructure as a code, etc., and everything is checked in. And you can manage the state of this infrastructure. And Git is basically your version control. I'm saying Git, but essentially it's any version control, basically holds your state of the system. So you can have a lot of things like declarative configurations. Once you store it in Git, you have version control, so you can control, big deal. You can do a continuous deployment from there. pull-based operation. So you pull, you change, the system detects, it automatically makes changes. You have a lot of observability. You have rollbacks. You want to see something went wrong. You have the version history available, so you can go back in time and recover from it. There are a lot of benefits for GitOps. So some of the benefits are tools, especially Argo CD actually kind of uses GitOps as a fundamental, but a lot of other tools like Jenkins, etc., use GitOps. But the principles are fairly general. For one, you have consistency, right? Git is your single source of truth. Whatever is stored in your version control is the truth. Otherwise, what you have is you have these different configurations across different environments. It gets really confusing and sometimes conflicts. You can easily collaborate because version controls are meant for collaboration. You have version and auditing. You have versions of how your system is evolving. You can go back in particular point of time and audit, see how things are working. So these are the main benefits of GitOps. I have about 10-ish minutes remaining. Okay, wonderful. I'm doing good on time. So now I'm actually going to move. So these up until now, I've talked about the general characteristics and principles and foundations of what cloud native CI/CD is. Now I actually move into some of the common projects that we have. Tekton project was basically the most common project, kind of starting project. There's a website. It's an open source project. The definition is powerful and flexible open source framework for defining shared and standard and shared components. Now, what does that mean? When we looked at Tekton is basically two things. It is a bare basic form of CI/CD tool. You can use it, but at the same time, it is basically a framework where you can use to build your own CI/CD. Now, what happens is that for a larger organization, a standard tool doesn't work. They have a lot of customization. So they have their own tool usually that works well in their environment. But the question is, if you want to implement a CI/CD environment, do you start from the beginning? So Tekton basically provides you components that you can glue. It's basically the architecturally, it's a loosely coupled components that you can glue to build your own CI/CD. So that's why I'm saying it's essentially a framework for building CI/CD. You can use it as a standalone tool, but it's more designed as a framework for building CI/CD. And Tekton is the basis for Rio. Rio is not an open source tool, FYI, but Rio is the tool that Apple uses. Now, if you look at a company like Apple, right, it's a big company with a lot of tooling, a lot of different environments. They build services, they build mobile apps, mostly iOS apps, of course, etc. So they need basically a tool which is quite infinitely scalable, works across different components. So their tool, Rio, which is not an open source tool, it's a closed source tool, uses Tekton as its basis. So Tekton, like Kubernetes, basically think of it as an excellent starting point for building your own CI/CD. So you don't really have to start from scratch. You just take these base components, glue them together, and customize your own CI/CD tool. So the vision behind Tekton was that it's composable, right? We have these independent components that you can compose, mix, and match. It uses a declarative syntax. We already saw what declarative syntax is. Containers would guarantee reproducibility, and it starts from scratch using cloud-native technologies. So some of the building blocks for Tekton is that you have the step. The steps are basically a single step, build, test, whatever. A task is a collection of steps, and then you have these pipelines that is asynchronous graph of these steps. And then these are coupled together with resources. So you can run those independent tasks, or you can run these pipeline with resources. What is an example of resource? A resource is essentially, say, Git repository is your resource. So I have this pipeline. I hook up this pipeline with my resource. So here is my Git repository. Here is my environment. I can run them. The history of Tekton is that Tekton came from a project called Knative. During my time at Google, I actually was involved with this project, Knative, and Knative had three components. So Knative, I don't want to go too much into details of Knative, but Knative was a serverless extension of Kubernetes. So adds a serverless layer to that. And they had three components. So one was eventing, because serverless is basically an event-driven framework. So you have an event generation, you have serving, how to route the traffic, and then you have build. And during that time, cloud native got really popular, and there weren't that good CI/CD tools out there for cloud native world. So what people did was they started taking Knative, and Knative had the same philosophy of using loosely coupled components. So rather than providing one tool, these build, event, and serving were three separate tools. There's a website, knative.dev, if you want to learn more about Knative, with three different components that you can actually use. And people started using build for CI/CD. And build became very popular, and it became so popular that it was decided that build should be made a project of its own. So they took build out of Knative, and Knative got renamed. Knative today only has eventing and serving, and build became what we call today as Tecton. So here is an example of Tecton. I'll go a little fast because I'm running out of time here. YAML standard pipeline, right? You have all of this build, test, deploy, etc. Then we go into Jenkins X. Jenkins X is spiritually similar to Jenkins, but in reality has nothing to do with Jenkins, just FYI. It basically is, it uses the same foundation that we want in open source, good for jack of all trades kind of tool for cloud native world. That's the similarity between Jenkins X and Jenkins, and that's where the similarities end. Jenkins X itself actually used Tecton components as its base. So it was created by James. He's famous in the open source world, but it was designed up to be a cloud native, Kubernetes native tool. And like Jenkins, philosophically, it was basically an automation server, which is fairly general, so you can use anything. It's an open architecture, so you have different plugins, tools to automate just about any task. Now, philosophically, it's the same thing as Jenkins, because that's what how Jenkins started. How does Jenkins works? You have hooks, user interface, you have clusters, controllers. Being cloud native, it supports Helm, Docker, etc. It's a fully open source project. You can actually download it. The difference between Jenkins and Tecton is that Jenkins uses Tecton, but Tecton's predominantly is a framework to build a CI/CD tool, whereas Jenkins is actually one instance of a CI/CD tool that uses that framework. So Jenkins is a finished product, whereas Tecton is kind of a semi-finished product, right? People who want to build their own tools will use Tecton, but people who don't want to build their own tools, they just want something cloud native that is open source that they can use out of the box, will go towards Jenkins X. Jenkins X, like Jenkins, supports many, many cloud providers, common ones being Red Hat, OpenShift, which is now IBM. I saw their booth outside, Amazon, AWS, Google, etc., etc. Okay, and Minikube. Minikube is essentially a Kubernetes similar for your local machine. So that's the Jenkins X. They have a CLI also. Benefits and drawbacks. Let's look at some of the benefits and drawbacks for Jenkins. Benefits, it's a cloud-native solution for Kubernetes, right? Simple automation of pipeline, shift left, agile philosophy, detect problems as early as possible. Ready-to-go pipeline, as I mentioned, it's basically a finished product, so it has ready-to-go pipelines. The drawbacks is that it has nothing to do with Jenkins. So if you are using Jenkins, you have to migrate pretty much everything. Traditional Jenkins servers are not supported, and UI is a little bit crappy. Most of the people, even Jenkins UI was not that great. I remember working at Snapchat, and they were like using Jenkins, and they have their own UI on top, which kind of abstracts away the Jenkins server. Anyhow, moving on, we're talking about Argo CD. Argo CD is predominantly a deployment. It's less of a CI and more of a deployment. People use Argo CD in combination with something else. Usually they might have like Tecton in the beginning for build and then Argo CD for deployment, but it follows the GitOps methodology, right? Same thing, you have your infrastructure as a desired state in Git, right? And then it ensures that match, and essentially, like Jenkins, is designed to automate fairly general, working predominantly on Kubernetes. Cluster, some of the salient features are that you have the Git, pull changes, Argo CD will sync up with your Kubernetes cluster. It has a web CLI, multi-cluster, multi-tenancy, which is what very much you need in a cloud world. GitOps will give you the ability to roll back and roll forward. and it can synchronize, has health checkup. Being an open source tool, it is very customizable. This is also true for Tekton. Tekton actually was designed to be very customizable in the first place and extensible. So let's do a little bit of, I have a minute remaining. So what I wanted to do was I kind of want to summarize and compare these three tools that I've talked about. Tekton, as I've repeatedly said, is essentially a framework, more of a framework, less of a finished product. Jenkins is an opinionated particular instance of a finished product that uses Tekton as its base components, but it's a cloud-native, built from scratch reincarnation of Jenkins. And Argo CD is similar to Jenkins, in fact, but different that it's more focusing on the deployments, and GitOps methodology is basically the centerpiece of it. Right on time. Thank you. Questions, if any.